Hello, everyone. This is now question 2 from the test 2 this year. And this question here is talking all about the basic survival food packs, in which case there are 4 jelly candies located within a pack. And each, there are 2 requirements that need to be met from the suppliers. And one of them is that they have 500 plus or minus 10% of calories per the whole 4 packs. And the other one is that each candy has no more than 60% starch. So each of these questions refers back to this question or this overall description. The first one, you want to calculate the heat capacity of a constant volume or BOM calorimeter if 10 grams of glucose produces a temperature increase of 23.464 degrees Celsius. You're also given the heat released by glucose combustion. So I wrote down kind of a partial equation here for glucose combustion. What it's telling you, so when you're burning glucose in a BOM calorimeter, so remember that's an enclosed space, they put it in, combust it, and measure how much heat is released from that reaction. For the reaction here, they're telling you that the heat released is, so it's released, it's going to be negative 15.547 kilojoules per gram of glucose. Now, in a constant volume or a BOM calorimeter, or calorimeter in general, the reaction that's occurring, all of the heat that's given off by the reaction, and I'll call that glucose, gets transferred completely to the calorimeter. So all of that heat will go towards changing the heat of the calorimeter. They're not changing heat, but towards how much heat the calorimeter is absorbing. So heat release is going to be a negative value over here. Now, we know this value here per gram, but here we're told that 10 grams raises the temperature by 23 degrees Celsius. We want to find Ccal. This is the specific heat capacity, or just the heat capacity of the calorimeter. So remember, we don't have anything in, say, a per mole or per gram when we're talking about the actual calorimeter, because it's an enclosed area, it's a particular piece of equipment. It's always going to have the same or similar one every time. So in this case here, that's what we're trying to find. Now we have to find, in this case here, the mass times this heat release, because we have 10 grams of it, equals Ccal delta T. So we can solve for Ccal. That's going to equal minus mass times the heat for combustion of glucose over delta T. So as you put everything in here, there shouldn't be any changes. You're going to have your 10 grams, you're going to have your minus 15.547, and then over, you don't have to change this, at 23.464 degrees Celsius or Kelvin, it's the same thing. So you end up with an answer in the end of, here we have 6.6259, and that is kilojoules per Kelvin. So there is the heat capacity of our calorimeter.